This lesson is on solving one and two-step equations. In previous lessons, we learned all about algebraic expressions. And there's two examples here of algebraic expressions, 3x subtract 4 and 5x squared plus 3. An equation has an equal sign in the algebraic sentence. So these are expressions because there's no equal sign. An algebraic equation will have an algebraic expression on both the left and right side of the equation. So here's an example of how to expand expressions and simplify expressions. And we can just complete this together now. 5x times x is equal to 5x squared. 5x times negative 2 is equal to negative 10x. Negative 3 times x squared is equal to negative 3x squared. Negative 3 times 2x is equal to negative 6x. After we distribute and expand out of the brackets, we're going to collect like terms. I'm going to write my x squared terms to be beside each other, and then my x terms beside each other. And then finally simplifying like terms. By now, hopefully we are comfortable with simplifying expressions. So we simplify expressions and we solve equations. So here are two examples of an equation. 2x plus 3 is equal to 3x subtract 2, and 4x subtract 5 is equal to 3. I know that these are examples of algebraic equations because there are expressions on the left and right side, and there's an equal sign in between. So when we have a variable in equations, we must solve for its value. When you see a question asking you to solve or find its root or find the solution, we're trying to find the value of the unknown variable in the equation. To do so, you need to isolate your variable so that it's alone on one side. Let's practice isolating our variables so that we can find the value of each variable. In A, we have x plus 3 is equal to 12. We want x to be alone. This plus 3, or positive 3, is in the way of x being alone on the left side of the equal sign. So what we want to do is we want to eliminate this 3. And we do so by performing its opposite operation. So if we subtracted the left side by 3, then this 3 and this negative 3 would cancel out. And then we would have x on the left side isolated. And that's what we want. But remember that an equation is a balance between the left and right side. The left side must equal the right side. That's essentially what an equal sign means. Think of it as a teeter-totter. You need to have the same equal weight on each side of a teeter-totter for it to be balanced. It's the same with an equation. The left must equal the right. Now I just inserted negative 3 on my left side. So now my left and right side are imbalanced. In order to rebalance this equation, I must also subtract 3 from the right side of my equation. So 12 subtract 3. And now my equation is balanced. You can add or subtract, multiply or divide any value into an equation. You can sub anything into an equation, but you must make sure that you are balancing the equation. So whatever you're subbing into the left, you must also do to the right and vice versa. So my left side has been simplified to x. Now my right side, I'm going to simplify 12 subtract 3, which is equal to 9. So my value for x is 9. I solved for x. Let's try b. X subtract 3 is equal to 12. My goal is to have x alone on either the left or the right side. I want x to be alone so that I can find its value. So again, this subtract 3 is in the way. We want to eliminate -3. So I'm going to insert its opposite, +3 or +3, into the equation so that I can eliminate this -3. So my next line is going to be x subtract 3 plus 3 is equal to 12. And now because I added a +3 to my left side, I'm also going to add it to my right side to ensure that there is continuous balance between my left and right side. Now these two will cancel themselves out. So x is going to be alone now, which is what I want. And I'm going to simplify my right side. The value of x for b is 15. C, this is a multiplication on the left, 3x. We read it as 3x, but we understand that it's 3 times x. 3x is equal to 12. In order to eliminate the 3, we need to perform its opposite operation. The opposite of multiplication is division. So 3x divided by 3 would then cancel out the 3's, and then x would be alone on the next line, which is what we want. Now, whatever you do to the left, you must also do to the right. 12 divided by 3. Also keep in mind that I'm using fractions to represent division. Instead of using the division sign, try to use fractions instead. In high school math, we move away from this division sign. We also, like I've told you many times, we also move away from the multiplication sign. So try to use fractions to represent division as much as possible. 12 divided by 3 is 4. X is equal to 4. Finally, in D, we have a division. X divided by 3 is equal to 12. In order to eliminate the 3, I'm going to perform the opposite operation, which is multiplication. So I'm going to multiply this entire fraction by 3. And then I also have to multiply the right side of my equal sign by 3 as well to keep it balanced. So these two 3's are going to cancel out. 3x divided by 3 will just equal to x. 3 times 12 is 36. Now we're going to move on to solving two-step equations. The goal here is to still isolate for our unknown. In order to do that, though, we need to perform two steps. So for A, we want to isolate B. So first what we're going to do is we're going to try to eliminate 8. To do that, we need to subtract 8 from both sides of the equation. So my next line is going to be 8, subtract 8, subtract 2b is equal to 11, subtract 8. Now these will cancel out. So we're left with -2b is equal to 11 subtract 8 is 3. We still haven't isolated b. We need to eliminate the -2 that's in front of the b. So I'm going to perform the opposite operation of multiplication, which is division. I'm going to divide both sides by -2 in order to eliminate the -2 and have b isolated on the left side. And we have a fraction on the right side of our equal sign, which is fine. The only thing I ask is that you don't leave negative signs in the denominator. So I'm going to just move the negative in front of the fraction. You can also move the negative into the numerator, but don't leave a negative into the denominator. Let's try b. So this time our variable is on the right side, which is fine. We still just want it to be isolated. So we'll start by eliminating -3. So I want to add +3 to both sides in order to eliminate that -3. Simplifying my left side, 8 plus 3 is 11. And now I want to divide both sides by 4 in order to eliminate the 4 that's multiplied by w. And I'm going to leave my answer in fraction form instead of converting it into decimal form. Now we're going to practice collecting like terms and simplifying like terms with solving equations. In question A, we have two x variables that we must find a value for. Because they're both the same variable, we're going to first collect like terms and simplify the like terms so that we just have one variable. Instead of two separate variables, we're just going to have one. And then we can solve for that value. The first thing I want is for my like terms to be on one side of the equal sign and then my other like terms to be on the other side of the equal sign. So I'm going to bring my 2x. I want this to be eliminated from my right side and I want it to appear on the left side. And then I want my +2 constant to be eliminated from the left side and reappear on the right side so that my like terms are on the same side. Another way of eliminating values is to actually just move them over to the other side of the equal sign. Up here, we would add or subtract the values from the left and the right side in order to keep the equation balanced. Another way of doing it is actually just moving them over to the other side. So this 2x is positive 2x on the right. On the left, it's going to turn into a negative 2x. And the +2, we're trying to move it to the right side. It's positive on the left side, but when you move it over to the right, it's going to become negative. Now I can simplify my left side because 3x and -2x are like terms. 3x minus 2x is 1x, but instead of writing that coefficient 1, I'm just going to keep it invisible. And -4 subtract 2 is -6. B. We're going to follow the same steps. We want our x terms to be on one side. It doesn't matter which side. And we want our constants to be on the other. You can solve for your variable either on the left or on the right, whichever one is easier for you. I'm going to try moving my x terms to the right side this time, just to give you that example. So my 5 is going to stay on the left side. And then I'm going to move my -1 over to the left, and it's going to become +1. My 9x isn't moving, it's staying on the right side. And I'm going to bring my 6x over, and so it's going to turn into a negative. Simplifying my left side to 6, and simplifying my right side to 3x. Now I'm going to divide both sides by 3 in order to eliminate that 3 and have x isolated. So x is equal to 2. And C, I have all of my terms on one side, and then my right side is actually equal to 0. So I'm going to collect and simplify my like terms all on the left before moving things over to the right. So my next line, I'm going to have my a terms written beside each other, and then my constants written beside each other. So 4a plus 7a is 11a, and -2 plus 24 is +22. And now I'm going to move my +22 over to the right side so that I can begin isolating for a. So it's going to become its opposite. And then I'm going to divide both sides by 11 to cancel out the 11, and so that a is alone. -22 divided by 11 is -2. Here we're solving an equation that also requires us to distribute. So first we need to expand out of the brackets, and then we can collect like terms, and then we can isolate our variable and solve for our unknown. 5 times y and 5 times -3. 5y subtract 15. Remember that there's a -1 in front of this bracket. So -1 times y and -1 times -2. -y plus 2. Next, I'm going to collect like terms. And then I'm going to simplify like terms. And now I'm going to begin isolating for y. I'm going to bring -13 over to the other side. So it's going to become +13. And then I'm going to simplify that. And then I can divide both sides by 4 in order to eliminate the 4 on the left. And so y is equal to 8. B, again, I'm going to distribute first. 2x subtract 6 is equal to -3x subtract 15. And then the -6 wasn't in the bracket. It doesn't need to multiply by anything. So we're just going to add on that -6 or subtract 6 at the end there. And I'm going to simplify my right side. So -3x, and -15 subtract 6 is -21. Now I'm going to collect like terms on either side of the equal sign. 2x is going to stay where it is. -3x is going to be brought to the left side, so it's going to become +3x. -21 is staying where it is, and I'm bringing -6 over, so it's going to become +6. 2x plus 3x is 5x. -21 plus 6 is -15. Dividing both sides by 5, x is equal to -3. C, I'm going to distribute the 5 into the bracket, 5x plus 10, and then subtract 3 is equal to negative 13. I'm going to simplify my left side before moving anything over. And now I'm going to bring the positive 7 over to the right side. That simplifies to negative 20. And then I'm going to divide both sides by 5. X is equal to negative 4. Last question. The 8 is going to stay as is. And remember, there is an invisible 1 in front of this negative. So we're going to multiply everything inside the bracket by negative 1, which means that all the terms inside the bracket are just going to change its sign to its opposite. And then I'm going to multiply negative 5 by w and negative 3. And then again, there is an invisible 1. So I'm going to multiply negative 1 by 4w and negative 3. I'm going to collect like terms on my left side and on my right side. And then I'm going to simplify like terms on my left and then simplify on my right. Now I'm going to start moving terms over so that the like terms are on the correct sides. 3w, negative 3w plus 9w is equal to 18, subtract 10. 6w is equal to 8, dividing both sides by 6. W is equal to 8 over 6. And I'm going to make sure that it's in the lowest terms, 4 over 3. There are some questions in the workbook for you to try and to consolidate your learning. If you have any questions, please either join the Zoom or you may email me. Great job.